Wowzers, that's been a lot of networking. And I really hope it was useful because I know it's taken a lot of your time to get through it. And believe me, it took a boatload of my time to create. And to be honest, I felt like crying more than once. So it's taken a long time. I'll skip the waffle and we'll get straight to the summary. All nodes in a Kubernetes cluster need to talk. How you pull this off is up to you. But we sometimes say that the nodes are on the node network. Cool, Kubernetes doesn't implement it, but it does need to be there. Then there's the pod network. Again, I suppose technically Kubernetes itself doesn't implement it, but it does expose a plugin interface for third-party drivers to implement it. The interface is based on the Container Network Interface spec, the CNI, and there are tons of companies out there with plugins. And when you build your Kubernetes cluster, one of the steps is to create this pod network. Cutting a long story short though, the pod network is big and flat, and every pod gets an IP address on it. So because of this, every pod can talk to every other pod, and every other node for that matter, right? Anyway, all containers in a particular pod share that pod's IP and network stack. Meaning, containers inside the same pod can talk to each other using ports on localhost. Magic? I do love it, right? But pods by their very nature are ephemeral, so they come and go all the time, which means you can't rely on them. Now I'm talking about specific individual pods here. We shouldn't be going to them directly, because as soon as you start scaling and doing updates and stuff, they're going to flicker in and out of existence. So to get around this, Kubernetes provides an abstraction point called a service, and there's two important things to know about services. One, they provide long-lived stable networking, so an IP, DNS and a port that will never change. And two, they keep an up-to-date list of healthy pods that match their label selector, so they always know when new pods are added and old ones removed. So, you create a service and it proxies or load balances requests over a bunch of pods that match a set of labels. Now there's a few different types of services, ranging from those that only work inside the cluster, all the way up to some that provision cloud-based load balancers with identities on the public internet. Long story short again, they're a reliable proxy or load balancer that we stick in front of a set of pods. Well, finally, we wrap the lesson up with a bit of theory explaining that there's this magical sort of network that all of our services get their IP addresses from. But rather than actually being a full-on network, it's really just a set of IPVS or IP tables rules that trap on service network addresses and rewrite destination IPs so that traffic gets forwarded to pods on the pod network. And with that, wow, give yourself a pat on the back. Hopefully, the fog of Kubernetes networking uncertainty has been well and truly lifted. Because like I said at the top of the lesson, I hear people all the time going on about how confused they get over Kubernetes networking. So the goal really was to turn on a light bulb or two, which I hope is what happened. But, you know what? If it didn't, and I don't want this to sound cheap, right? But honestly, it might be worth you going back and watching the lesson again, and maybe not at 1.5x speed or anything, because we are covering a lot. I just know that I personally learn a lot when I hear things more than once. Either way though, thanks for watching, but I hope you got plenty of enthusiasm left, because next up is storage. Bring it on.